In this lesson, we're going to talk about healthcare dosages. Before we get started on this lesson, I would like to remind you to go to your student resources, which are in your in-class notebook pages. And in your student resources, these are some that you might want to look at now, or in the middle of this lesson, or after the lesson if you feel like you've got holes. In other words, you've got some spaces of not sure what's going on or how that got reduced or what was going on inside the process. You might want to consider looking over dimensional analysis, equivalent fractions, multiplying and dividing fractions, ratios and fractions, and rounding and estimation. And yes, that was a cuckoo clock. But we are going to do healthcare dosages. I'm going to do 2 problems. The rest will be for you to do, but these 2 are representative of what we're looking at in these dosages. So starting with the first one, we will start with number 1. And looking at number 1, there are some directions, and then it says let's use this for questions 1 through 4. So I'm going to do number 1, and I'm going to do number 6 in the bottom part. A reminder that we may not know what all of these words stand for, but we can do some math and do it accurately. And that's the bottom line, is that whatever we're doing, we do it accurately, that we're not overdosing or underdosing patients. So it says there is an order of amoxicillin. It does give this, and the 12.5 milligrams per kilogram look worth writing down, at least to get us started. Here is a child that's 26 pounds, not sure what to do with that right now. But they want us to give how much milligrams. So in the end, our question is how many milligrams. So no matter what we do over here, we're going to have to make sure that through dimensional analysis, we get it down to just milligrams. And, well, that's it. So when we do dimensional analysis, my brain is thinking I might need to throw in a couple of 3 more, don't know how many, fractions, to get the job done to where I'm only looking at milligrams. Well, while we're here, that milligram is in the numerator, which is a great place, and it can stay there, but I've got to deal with the kilograms. When I look at the main problem, I don't see anything with kilograms, but if I look at what's given up here, I do have one with kilograms that just happens to have pounds. So I'm going to go ahead and set this up, because we had 12.5 milligrams for every 1 kilogram that a child weighs, but this child weighs pounds, not kilograms, so we've got to do some conversions. So here's a conversion. I'm going to go ahead and put the 1 kilogram in the numerator, because I know I want my kilograms to go away, and they can't go away side by side. One's got to be in the numerator, and one has to be in the denominator. But it says it's 1 kilogram for every 2.20 pounds. It's not obs, but yeah, it works. And that's awesome, because now that I have removed those, or put those in there, it will remove my kilogram unit. So I'm almost there, except they want the answer in milligrams, not milligrams per pound. They just want plain milligrams. So I've got to do something to kill the pounds. Well, they told us the child weighs 26 pounds. So let me do 26 pounds, obs, per, and if I need to write something down, I can say per child, per 1 child, or I can just put it over 1. It's very legal to put a number over 1. And when I do that, my pounds are going to disappear, and then all I have left are my milligrams. And through dimensional analysis, I am able to get what I need. I'm going to need to multiply the top parts together, and then use the vinculum, divide by, well, all I've got down here is just a 2.20. So let's see what happens, and in the end, they want us to round to the nearest hundredth. So here we go, hit clear a bunch of times, clear, clear, clear. And let's do the numerator first, which is 12 5/10 times 26. That gets us what's in the numerator, but I'm supposed to divide by what's in the denominator. And the denominator has a 1 and a 1, and anything times the 1 is just going to be that number, so we don't even have to consider those. We can put them in if we want, but it won't change the answer. And so what I get on my screen is 147.7272, and we're repeating that 72 on and on and on and on. If they want us to have our final answer to the nearest hundredth, the nearest hundredth is right there. That's the hundredths place value. So I look beside it, and that 7 is greater than 5, so that means my hundredth number's got to go up 1, and everything behind it turns into a 0. So I have 147.73 milligrams. That's how much I'm supposed to give in the amoxicillin for each dose for this 26-pound child. So that finishes number 1. And this is a great time for you to stop the video, and then for you to keep, sorry, I don't need to be turning pages and talking. This is a great time for you to stop the video, review what we did together, and then put away all your notes, and then go back to try to do this from start to finish all by yourself. You may want to wait until you finish the whole paper so that you have a chance to kind of forget it, and then go back and see how much you know. We're now moving to the bottom of this page, and at the bottom of this page it says to use the following conversions here as needed for questions 5 through 7. We're going to do question 6. So question 6 is right here. And wow, they don't give us a whole lot at all. They just say here's the order, here's what's supplied, how many tablets per dose, and use decimals, not fractions, if that's what we end up with. Whew, so here we go. We got to start somewhere, and then we got to move everything around according to the dimensional analysis and the need to get rid of. I throw up 3 of these just because I usually need 3. I may not need 3, but in the end, I'm looking for how many tablets. 1 tablet, 2 tablets, 12 tablets. What's it going to take for this order and what is supplied? So I like to just go ahead and start with what's given. They gave us 5/10, what is that, milligrams of some medication. And that 5.5 milligrams, I'm not seeing anything to go with it other than it's a dose, it's the order, per order, or I'm just going to put 1 and see how that works out for us for now. Might have to come back and make some adjustments. So if I'm trying to get down to just tablets, I don't need milligrams. I do have a number back here that has mcg. So I've got milligrams, I have mcg. Let's see what's available in our conversions. When I look at our 2 conversions, I have a gram and a milligram, and an mg and an mcg. So 1 milligram is the same as 1,000, I don't know what this might be, mcg. Like I said, I may not know what all of these things are, but I can sure put the numbers together and can sure do the mathematics accurately. And so if the conversion here has a 1 milligram, I need my 1 milligram to be in the denominator, because I need my milligrams to go away. I need my units to go away, and they can only go away top to bottom, not side to side. But if I'm going to put in 1 milligram, I have to put in its equivalent of 1,000 mcg. So I have 1,000 mcg. So using dimensional analysis, trying to get from where I am to where I need to be. So I started with the 5/10 mg. I was able to get rid of the mg with the conversion that is given to me on the other page. And I'm not where I need to be. I still have mcg, and what I need are tablets. And so let's look right here. What they supply, what they have in their cabinet are 500 mcg tablets. And so now, oh, how am I going to do it though? Because I know that these are tablets. I know that my mcgs are in the top. I need it to only be the word tablet. So let me go ahead and take what they have, 500 mcg. I chose to put it in the denominator because I need the mcgs to go away, but I do need something here. And so it tells us that for every 1 tablet, it is worth 500 mcg. And this is awesome because my mcgs, my units go away. I have no other unit than a tablet. which is exactly what I need to be in the numerator so that I end up with tablets. I need to multiply all of my numerator together. I need to then divide by everything in my denominator, which is technically just a 500. So let's see what's going on here. We're going to hit clear a bunch of times, and I'm going to do 0.5 times my 1,000, and I like to hit equals. That just signifies I'm done with the numerator. It's like parentheses. Now I'm going to do divide by what's in my denominator, which is 500. And when I do, there we have it. What I need for this particular order, based on what is given in our supply cabinet, this person is not going to need 1 tablet. They're going to need 1 tablet, and I don't have to worry about the decimals or fractions, per dose. So this concludes our lesson on healthcare dosages.